Okay, the last thing we want to teach is percent yield. Percent yield is probably the most difficult for students to understand because it seems like they've given you an answer. So what I want to do is give it to you in word form and show you how to go backwards and draw the problem and then come up and use your flow chart. So remember, the flow chart is something that develops your math. So for you to draw this with all of your problems on this upcoming test is one of the smartest things you can do. Do not think that drawing this is an issue. So here we go. Here's my word problem way down here. We have a scientist reacting 96 grams of oxygen, and he collects 100 grams of water vapor. And we know that oxygen and hydrogen make water, okay? And the question is, what is the percent yield? So what we want to do is, first thing you want to make sure is you have a balanced chemical equation. So we have to add in our numbers for our balancing numbers. We've touched that all along. But then we want to draw a visual of what's happening. They gave us 96 grams of oxygen and 100 grams of water. So I'm going to come back here and put 96 grams below the oxygen. I'm going to put 100 grams below the water. Okay? So now the question is, what is the percent yield? The percent yield means how much of the product that they could have made was actually made. So think about it this way. Whenever you're doing an experiment and you put one container in another, you actually lose some because as you go from one container, you lose some liquid. It may get trapped in the bottom. It sometimes can spill out on the table. We know in experiments, a lot of times product is lost just from the transfer from container to container. Maybe in an experiment when you're making gases, the seal breaks a little bit and a little bit of gas sneaks out. That can happen as well. So what happens is in these percent yield problems is they're going to give you the answer to one of the things you need to check for. So in this problem, I want to find out how much water could we have made. Now it says they made and collected 100, but you know what? They could have made more or less. And so we got to compare that. So percent yield is a two-part problem. First thing you got to do is you got to find a theoretical yield. And a theoretical yield is an answer that comes from a flow chart. Okay? And so in this theoretical yield, we're going to figure out how much water could we have made in grams. Okay? And so we're going to save this number to the end. Okay? So what we want to do is I want to give it to you in steps. So the first step is we want to find out what is the theoretical answer for water. How much could we have made for that product? Okay? So this is called an actual yield. And what we're going to do is we're going to compare these two numbers and come up with a percent yield. And so to find the percent yield, we'll just put a little percent sign here. Percent yield is when you take a actual yield, which you did get in the lab, and you divide it by the theoretical yield, and you then times it by 100 to make it a percent answer. Okay? So I need that symbol there. There we go. So let's do the problem. We're going to do step one. Step one, a theoretical answer, is what comes from a flow chart. These are theoretical possibilities. So I want to find out theoretically how much water could we have made. Okay? So we're going to do a mass to mass problem with oxygen and water. Okay? So we're going to write oxygen and water above our charts. We're going to go from a mass to a mass, and we can see it is 3 jumps. Okay? So we're going to write down our given number, 96 grams. So you're always starting in a theoretical yield, percent yield problem, with the reactant. Okay? So we're going to do our 3 jumps. And we're going to see what kind of answer we get, and we're going to compare it to this 100. So that's what makes these confusing. They've given us an answer, but it's something we want to use later on. It is not the answer we need from the problem, so we need to find the theoretical answer. So we got our 3 jumps. Mass to mole. Mole goes on top, weight on the bottom for oxygen. So we're going to flip it over. Mole goes on top, water or oxygen weighs 32, 16 times 2, and then we have the first jump. The second jump is mole to mole. Coefficients again, no matter where we're jumping, it's always the coefficients. So the one we want goes on top, so it's 2. We're coming from the oxygen problem, so we're going to put a 1 on the bottom. Okay, that's the second jump. The third jump is the formula of mass, again, the molar mass, but we're in water's chart, so we want the mass on top. Water's mass is 18, and over 1 mole. If we've done it correct, grams cancel out, moles will cancel out, and the 1 gram is left, so that's our gram answer. And so now we do our math. 96 divided by 32 is 3. 3 times 2 is 6. And then 6 times 18 is 108 grams. So, this is what it's telling us. From this math, if I could have used up all this oxygen and been very, very, very careful, I could have collected 108 grams. But we know that when we've done experiments, and you've done it too, it's not easy to get perfect results. So in this experiment, somehow 8 grams were lost. Okay? They could have escaped from the container, maybe the transfer from container to container. So this was their actual yield that they got. This was the theoretical amount they could have got. Percent yield is simply comparing the two numbers. So to find the percent yield, all we have to do is one more problem. We're going to take our 100 grams that we did make it from our question over here, divided by how much we could have gotten, 108 grams, and then we times that answer by 100 and get a percent yield. So I take my calculator, real simple, and I go 100 divided by 108 equals 0.2959 times by 100, and it gives me 92.59 or 92.6%. So they're in the 90 percentile range. So they did a pretty good job in their experiment, and so there you go. That's how you find percent yield.